CTC only survive within the inner horizon. They call it a quadrature horizon. However, let's imagine if the light cannot, if the dr dt will close to 0 on that horizon, that means the light will have a blue shift while it close to this horizon. And that means all of the energy of the light or all of the mass of the light will have an infinity blue shift. That means there is the mass inflation. And this mass inflation will cause the quadrature horizon extremely unstable. So that's why the researchers think the quadrature horizon will make the CTC become impossible to survive. So although mathematically we can find a solution from the Kerr matrix that time travel, human can conduct time travel. However, physically, CTC it seems not realized because we will crash the boundary of the quadrature horizon. Yeah. So that is the, but I will still not say the story is not true. Possibly in the future, there are some genius researcher to find another solution for the time travel. So let's keep expecting. So the conclusion is that about the time machine controlling system. First, we cannot generate a microscopic black hole, Kerr black hole using the LHC so far. And the second, it seems that the CTC cannot survive due to the quadrature horizon, due to the mass inflation, due to the infinity blue shift. So this theory is not real. Time travel remains only the mathematical possibility, but not the physical reality. And that's all. Thank you for your attention. Yeah.
Another excellent presentation. Any questions, comments?
It's like a steady discussion for the cosmology course.
What's this?
Stan's case. Stan's case is the new name called by the Okabe. And these words indicate the stone.
Okay.
And this word is the gate. That means it used this word to name the one of the world line is the most stable one. Mm-hmm. And that world line is what he expects. So he believed if he keep going to keep find the true method to achieve that world line, everything will be perfect because he suffered a lot of the difficulty in the story. So that's why it is common to say it is the choice of the Stan's gate. Yeah. Sure.
I was just wondering when you were talking about the closed time loop within the parallel world.
Next one?
The one before.
This one? Okay.
Okay, anyway. I was just wondering if according to theoretically, would that be just a random or the closed time loop? Would that be random or would that also be related to causality?
Sorry, I can't understand your question.
So,
do you mean that illustrations? This one?
Yes.
Okay, and I can try to explain more about this figure. This figure means the direction of the light cone is point the phi direction. So what I mean, that means the future is not described by t, it's described by phi. So that means the future, for example, if there is a phi 1 and phi 2, The future is on the phi 2. It's not a T2. Yeah. So that's why. Oh, that is a very interesting point. Why we call the ds squared lower than 0, we name it as time-like. Because in the general relativity, t is not exactly equals to the evolution of the events. So time-like means this axis possibly indicate the passage of the event. So the time is not corresponding to that in the general relativity.
So would that also mean that the event is not a single line? There could be different events related to a single event, as in like.
It's up to you how to describe the events. If you describe events using the space-time matrix, like dt, dr, d phi, d theta, something like that, the events will draw by here. So it's hard to say what's the direction of the event because it's a high order description. But if we're using a mathematical description just from the equations, we can see it's only relevant to the phi. Yeah. So that's the only true things for this description. It's okay. It's a little bit complicated,
Yeah,
no?
Yeah, it's a bit difficult to understand. But if that was the case in the anime, does it have any relation to why did it switch to 7 days? Just 7 days ago.
You mean, yeah. Actually, I try to ignore to mention the time machine mention, the real instrument in the story, because it's more complicated. They mentioned a lot of some other machines. It's not solely relevant to the theory here. Mm-hmm. So yeah, I think I can only answer the question about the theory. Yeah. Sure, enjoy.
How similar is the time traveling aspect in this compared to Interstellar?
Interstellar?
Yeah, have you seen the Interstellar? Like they also use a lot of dimension and time traveling.
Do you mean how could we?
Yeah, they go through like.
I think it's about black hole, but they have used a wormhole to.
Yeah. They have a black hole and they go in. Have you seen the movie?
In the animation, they didn't show that. They didn't show the real scenario how they put some guys into the black hole. Actually, they use some alternative method. Actually, they have the 3 different time travel. There is a D-mail in the time leap and the real time travel for the real matter. For the first 2, it's highly relevant to this. They just send the information. For example, they only send the information lower than they mentioned the precise value is 32 bytes into the machine. And then, because in their theory, the microscopic black hole can be generated by LHC, but only within the time interval about 10 to minus 32 seconds. So at that quite short second, they try to put the information into the machine. And then at that moment, the information will pass through the crusher horizon and go into the CTC. So because the as I mentioned, CTC is quite unstable, right? So at a short time later, CTC will broken. And that moment, information will escape from the black hole. And then at that moment in the story, that moment have already back in time. Yeah, it is a more detail about the instrument, but it is. Do you think we can do that? Sure.
So, the CTC, if you use the curve metric, right? So, to have this kind of loop, so you eliminate the TG's part.
Yeah.
And then You only use a phi part.
Yeah,
Right.
assume the dt is 0. But you need to notice that dt here not indicate the passage of the event, or not indicate the evolution of the events. Because in the flat universe, for example, in the Minkowski matrix, there is the constant time tensor flow along the t-axis. So we always think that t can express the evolution of the events, right? But in this scenario, that's not correct. In this scenario, dt just indicate one axis, not indicate the evolution of the events. So we assume dt equals to 0. That means we assume in the space-time there is no separation of the dt of the t, that axis. However, we still have this term, right? In this scenario, this term could be lower than 0. If it's lower than 0, that means this phi will be time-like. So at that moment, phi is the indicator of the passage of the evolution of the events. Yeah.
So you mean that is it in the same dt? So because the dt is 0, so there is no separations between two events.
dt is 0. That means on the axis of t, there is no separation. However, ds still is smaller than 0. That means it is a time-like. That means there is the space-time event separations. Yeah, it's hard to image, but it's interesting.
And one more thing, and like what is the mass inflations? So which mass have an inflation? Because
as I mentioned here,
you mentioned that light have a mass.
Yes, because the energy. The problem is energy. So if there is an infinitely blue shift and the line will stay on the Cauchy horizon, that means the energy of light will have an inflation of the energy. And using the mc square, E equals to mc square. And the relativistic description of the energy for the light. Yeah.
So I think for the light is E equals P times C, not mc squared, right?
Yeah, but yeah.
Light is massless, so because light is massless, so you can define the causality according to QFT, and then.
Yeah, that's correct. That's correct. But okay, I cannot explain it very clearly because I found for the description of the CTC there is a mass inflation. So I mentioned here. Maybe I have some mistake about that. But the most important thing is there is an infinitely blue shift. Yeah.
Maybe that's for matter. I don't know.
I see.
I think Vida has a question.
Oh, sure.
Okay.
How to?
Hi Vida, do you have any question?
Is your volume? Can you put the volume mute
Oh,
so that maybe we have an echo?
let me try.
No, it was already answered. Thank you.
Is there a question?
You have a question or not? Vida, do you have a question or not?
No, it was already answered.
Oh,
Okay.
oh, sure.
Okay, if no more questions, shall we move on to the quiz?
Kahoos.
Yeah. I found it also has a game.
Really?
Yeah.
Oh, I didn't find that.
Maybe you should play it.
Oh, sure. Host life. Is that while I generate the Kahoot system, I can generate the games on the platform? Does you mean?
No, I mean the Steins Gate.
Oh.
It says it's actually from originally a game.
Oh, really?
And the anime came out from the game.
Oh, yeah.
Oh,
It is
okay.
wrong because it is quite. Because that situation is that because they have several word line, right? And that game is like a Gale game. So if you do a different choice, you will get into a different end, different result of the story. So it's quite useful for this kind of the Gale game.
Yeah, I can imagine it's good to.
Do you want to try that?
Yeah, I'm interested now.
Yeah. Actually, a lot of information just mentioned in the game. Yeah. So if you just watch the animation, you will lose a lot of information. Yeah.
Everybody in?
No, it's problem. It's normal.
Is it internet problem or?
Probably I'm trying my computer instead.
Okay.
How many?
Not validate pin.
How many participants we should have? Is it 13 or?
Is there a limit?
I'm not sure. Because 11 student hotel.
Okay. So
No, that's for me.
yeah.
Should we start?
Everybody in?
Okay,
Let's
start. Quiz 1, what is the email? Oh, so a message sent to the past. Yeah, it's not sent to the future. Wow, yeah, Dora.
Oh, Dora is excellent.
Yeah. Oh, sure. I need to press the next. Okay. Second problem. According to their Z program, time travel requires what? Oh, okay. They need the microscopy rotating black hole. Oh. Third questions. What is the defines a black hole event horizon? That's right. Everyone professional on their general relativity. A curve is time-like if what? Okay, the answer is that it moves slower than the light. That means there is the causation between different events. So the fifth, what's different between the curved black hole and the Schwarzschild black hole? Okay. Oh, all of the black hole have a horizon. Lily, congratulations. Then CTC in the curve solution appear in what kind of the scenario? Yeah, there is a dip inside the inner crotchet horizon. Okay. This one, oh, it's a little bit difficult for these questions. What is the crotchet horizon? Okay, yeah, that's right. Because we see the causal horizon, it will appear the CTC. That means we cannot predict the future if we know everything, even though you are the Laplace monster. So the final questions? I just show you a delta function. It's a hint. Yeah. Okay, that's all. Oh, third. Oh,
Good.
Bahara.
Oh, good job.
Who is the?
Oh,
Oh, yeah.
we need to beat him. He's a team. Oh, good. So Bahari gets a point?
Yes.
Yep. But okay, we should work together to beat him. Okay, thank you very much.
Yeah,
for coming.
thank you everyone.
Good presentation, good
Thank you.
points. Okay. Okay, so maybe we don't have much time left, so maybe